In this session, we're going to see how to divide polynomials, and in certain cases, this can lead to a process called synthetic division, and so we'll see how that works. Before we get into dividing polynomials, let's refresh ourselves on how to divide numbers. Suppose I need to divide 164 by 3. Well, this is long division, so I'm going to put 164 in the division house thingy, and the 3 on the outside. And the way we divide, it's a 3-step process that we just perform multiple iterations of to get to the final answer. And the first thing we need to do is divide. And so 3 divides into 16 5 times. And at this point, I'll ask a class, what do we do next? And usually they'll say subtract, blowing right past the fact that we need to multiply so we know what to subtract. So I'm going to multiply 5 by 3, and I'm going to get 15. And then we subtract that 15 because division is really repeated subtraction. So when I subtract that 15, I end up with 1. We bring down the 4 and do it all again. Now I'm going to divide. 3 into 14 goes 4 times. Then I'm going to multiply. 4 times 3 is 12. And then I'm going to subtract that 12, and the answer I'm going to get is 2. And now we can express this as 54 2/3 as our final answer. So we can say that 164 divided by 3 is 54 2/3. Alternatively, as you may remember from grade school, you might have written this as 54 remainder 2. And it's kind of important to know this because there's vocabulary involved with dividing. The 164 that we were dividing into is called the dividend. The 3 that we divided by is called the divisor. The whole number answer that we got, the 54, is called the quotient. And as I'm sure everybody remembers, the 2 is the remainder. And when we wrote down the 54 2/3, we were expressing the answer as quotient and remainder divided by divisor. And that'll be useful to know because sometimes a book will ask us to express the answer in that form. Do you remember how you would check a division like this? We would take the quotient, multiply it by the divisor, and then add the remainder to make sure that our answer is correct. And in this case, what that would look like is 54 times 3 plus the remainder of 2, and a quick computation. And it's a quick computation to verify that the answer that we get is indeed what we started with, 164. But I want to point out, you got quotient and remainder over divisor. That's one way to express what we've done. And then a way to verify that our answer is correct is to multiply the quotient and the divisor and then add the remainder to the result. Well, let's get started with our first example. Here we have 2x to the 4th minus 3x cubed plus x plus 1 divided by 2x squared plus x plus 1. And the first thing I want to point out is that this is a polynomial, 2x to the 4th minus 3, all that stuff, divided by a divisor, 2x squared plus x plus 1. And I only mention that because later we're going to be talking about the divisor. I want to make sure we're all on the same page. So we're going to do this division using the 3-step process that we would for numbers, but there are some other things to consider since these are polynomials that we're dividing. And the first thing is, I need to make sure that all the terms are present in the dividend, the original polynomial. So 2x to the 4th minus 3x cubed, and I'm going to throw in a 0x squared. You might remember that you were told 0 is a placeholder, and we're indeed going to use 0 is a placeholder in this case. Reasons for that will be evident in just a moment. That goes inside the division house thingy, and outside we've got 2x squared plus x plus 1. Now, there is this three-step process. In the first step, we divide. And with polynomials, we're going to divide the first term of the dividend by the first term of the divisor. And off on the side, we might consider that it's 2x to the fourth divided by 2x squared, result of that being x squared, the 2's divide out. And so x squared goes above the 2x to the fourth. That's going to be part of our quotient. Now remember, the second step is to multiply. When we multiply, we're actually going to multiply by all the terms of the divisor. So if we break out the rainbows, we get x squared times 2x squared is 2x to the fourth. X squared times x is a positive x cubed, and x squared times 1 is a positive x squared. And here we can see why we wanted to throw in the 0x squared. Now, when I want to subtract, which is next, I'll be able to subtract like terms. Well, to tell you the truth, I'm not actually going to subtract. I'll write down the s because that is the next step. When I say I'm not really going to subtract, what I mean is, here we're subtracting the result of that multiplication. In other words, we're subtracting a polynomial, which really means change the signs of all the terms and make it addition. When I do that, 2x to the fourth minus 2x to the fourth, well, that goes away. And if that doesn't happen, we've done something wrong. For the next terms, negative 3x cubed minus x cubed, that's going to be negative 4x cubed. And then 0x squared minus x squared, well, that's why we lined up our like terms so that we could take care of that easily. And then let's go ahead and bring down the plus x and the plus 1. And since I've brought those down, I don't need them anymore. Now we're ready to go again. What do? Divide. When we divide, it's the first term into the first term that's left down there. And in this case, what that's going to look like is negative 4x cubed divided by 2x squared. Result of that is going to be negative 2x. So, minus 2x in the next place up there in the quotient. And then, let me clean this up just a touch. Now we're going to multiply. When I multiply, we're going to break out the rainbows there. And negative 2x times 2x squared is negative 4x cubed. Negative 2x times x is negative 2x squared. And negative 2x times 1 is negative 2x. What's next? Subtraction. Subtraction means we're going to distribute a negative. All those signs in there change. Now it becomes an addition. And the negative 4x cubed plus 4x cubed goes away. Again, that has to happen every time. Negative x squared plus 2x squared is x squared. X plus 2x is a positive 3x. And then I'm going to bring down the 1. Now it's gone. Guess what we're going to do next? Divide. When I divide, let me scroll that up just a bit. It's going to be the first term of the divisor and the first term of what's left after we subtracted. And that's going to look like x squared divided by 2x squared. The x squareds divide out. We're left with 1/2. Ew, I know. Now we're going to break out the rainbows again because the next step is to multiply. 1/2 times 2x squared is simply x squared. We're going to subtract, aren't we? That means change the sign. Might as well do it now. 1/2 times x is 1/2 x. That would have been positive, but we're going to change that sign. Again, we would be distributing a negative like we had in the previous steps. And then finally, 1/2 times 1 is a positive 1/2, but we're going to change that sign because we're subtracting. And if I can get just a little more room down there, x squared, subtract away. 3 minus 1/2, I'm going to write that as 5/2 attached to x. And 1 minus 1/2 is positive 1/2. We can write this, if we want, as the final answer, x squared minus 2x plus 1/2 plus 5/2 x plus 1/2 divided by 2x squared plus x plus 1. And what we have here is quotient plus remainder over divisor, just like that mixed number. Depending on what we are asked to answer, we have different ways we might express this result. For instance, if I'm asked for the quotient and the remainder, well, the quotient is x squared, let me peek up there, minus 2x plus 1/2. Yeah. The remainder is 5/2 x plus 1/2. That could be one way I'm asked to express the answer to this for a textbook homework problem or on a test. Another way could be to say, you know, when I divide, let me rewrite the original problem here. Hang on. It could be that I want to express the division as you saw above, the quotient x squared minus 2x plus 1/2 plus the remainder 5/2 x plus 1/2 over the divisor 2x squared plus x plus 1. That could be an acceptable form for an answer if that's what I'm asked for. Alternatively, I could be asked to essentially show how I would check the answer. Remember that checking the answer, go back to a previous slide, would look like quotient times divisor plus remainder. And in this case, that would look like the original polynomial, 2x to the fourth minus 3x cubed plus x plus 1 is equal to the quotient x squared minus 2x plus 1/2 times the divisor 2x squared plus x plus 1 plus the remainder. And again, right above that we have quotient plus remainder over divisor. I'm going to circle this as a possible form of the answer, but again, you're looking for the instructions. If the instructions say divide, quotient plus remainder over divisor, there it is. If the instructions ask for the quotient and the remainder, just give those. And if you want to check your answer, or in some cases you're asked to express the result as quotient times divisor plus remainder, well, that's what it'll look like. On to the next. Here we've got 3x squared plus x cubed plus 4x plus 3 divided by 3x plus 6. First thing I want to point out about this is that the dividend, the original polynomial, is not in descending order. Descending order refers to exponents, and the exponent that's biggest should be first. If you don't have that, this process just doesn't so much work. So x cubed plus 3x squared plus 4x plus 3 inside the division house thingy, and 3x plus 6, the divisor outside. And our three-step algorithm is divide, multiply, and subtract. Why don't you give this one a shot? Pause the video, divide it out, and then hit play. Okay, so when we divide the first term of the dividend, x cubed, by the first term of the divisor, 3x, and I'm going to write the resulting division as 1/3 times x squared. It just makes it easier for me to think about stuff. So 1/3 x squared is the first term in the quotient. Now we're going to multiply. We're going to break out the rainbows. 1/3 x squared times 3x is, oh look, x cubed. Check it out. We're going to subtract next, aren't we? Let's go ahead and do that. Change the sign there. 1/3 x squared times 6 is going to be positive 2x squared, but we're going to subtract, so let's change the sign. Alright, so x cubes go away, and we're left with x squared, and I'm going to bring down the plus 4x and the plus 3. Now, we're going to divide again. The first term into the first term, so x squared divided by 3x. Looks like we're going to end up with a fraction again, 1/3 x. So plus 1/3 x. Now we're going to multiply, break out the rainbows there. X squared plus 2x. Change the sign on both of those because the next step is subtract. And finally, we have 2x plus 3. We can do this all again. So, divide. First term into the first term. That's going to look like 2x divided by 3x. X's divide out. I have positive 2/3. For multiplying, we break out the rainbows. 2/3 of 3x is 2x. Change that sign. 2/3 of 6 is 4. Change that sign. And we have 2x plus 3 minus 2x minus 4. 2x's are going to go away. We're left with negative 1. Now how am I going to write this? I'm going to write it as quotient 1/3 x squared plus 1/3 x plus 2/3 plus remainder over divisor, but check it out, the remainder is a negative 1. So I can put that as negative 1/3x plus 6. If you really wanted to, you could say it's plus with the negative 1 in the numerator there. I don't really care. I'm going to say that's good enough for me. If you needed to identify the quotient, you could do so. If you needed to identify the remainder, you could do so. Cool. Our next example is 4x cubed minus 3x squared plus x plus 1 divided by x plus 2. A couple of things we want to check. Number 1, is this in descending order? The exponents in the original polynomial, the dividend, are 3, 2, 1, nothing. That's in descending order. Good. Also, all exponents are present and accounted for. So, why don't you pause the video, give this one a shot, and then hit play. So 4x cubed minus 3x squared plus x plus 1 goes in the division house thingy, and x plus 2 goes on the outside. First, we're going to divide, and the result of 4x cubed divided by x is 4x squared. Then we're going to multiply. Don't forget we distribute on that one. 4x cubed plus 8x squared. And since we're going to subtract, we change those signs there. And 4x cubed goes away. Negative 11x squared. Bring down the plus x plus 1. Because I've brought them down, I don't need them anymore. I'm going to cross them out. And do it again. Divide. Negative 11x squared divided by x is going to give me negative 11x. Multiply. We're going to break out the rainbows. And that gives me negative 11x squared minus 22x. And then for the subtract, we're going to just change those signs there. The x squared terms go away. We have 23x plus 1. Divide yet again. X into 23x. Well, that's going to give me a positive 23. Multiply yet again. And let me scroll that up just a touch. That gives us 23x plus 46. And then subtract yet again. which means change the signs on those terms. The x terms go away. We're left with negative 45. So our answer could be expressed as 4x squared minus 11x plus 23 minus 45 over x plus 2. That could be one way to express this solution. If we wanted to check this solution, then we might do so by multiplying the quotient times the divisor and then adding the remainder. And let me write all that down. Here I have the quotient, 4x squared minus 11x plus 23 times the divisor, x plus 2, and then plus the remainder. Well, that remainder is actually a negative 45, isn't it? And I want to check this one because some of these answers, these numbers seem a little suspect to me. So let's see what this looks like when we multiply. 4x squared times x, 4x cubed, 4x squared times 2, 8x squared. And then negative 11x times x. I'm going to put that, since it's x squared, under the other x squared. Collecting my like terms will make things easier for myself. Negative 11x times 2 is negative 22x. And then finally 23x. And then 23 times 2 is 46. Let's not forget the remainder that we had, 45. Collecting our like terms is going to give me 4x cubed minus 3x squared plus x, and then 46 minus 45 is plus 1. And check it out, that 4x cubed minus 3x squared plus x plus 1 is what we started with. It should be. Okay, let me clean some of this up here. Hang on. Alright, so I couldn't really clean it up, but here it is again. Okay, this is the completed division problem that we just did. And there's something I want to point out. The divisor in this case is of the form x minus c. Now in this particular case, if x plus 2 represents an x minus c, that means we really have x minus negative 2, but that's something that's useful down the road a bit. For now, I just want to point out that the divisor has a leading coefficient of 1. And it's linear. The exponent on the variable is 1. And if the divisor has a leading coefficient of 1, when we divide into that 4x cubed, the first term, the 4 is going to remain a 4. And just to remind us, we divide, then we multiply and subtract, and once we do that, we're at this step here, the negative 11x squared plus x plus 1. And when I divide that 1 into the negative 11x squared, the negative 11 doesn't change. And then we multiply and subtract. We end up at this stage here where we have the 23x plus 1. And again, the divisor having a coefficient of 1 means that the 23 doesn't change. Seems that these numbers tend to repeat. And another thing I want to point out is when we subtract, those were the ones that went away, right? What were we left with? Well, 4 times 2, and then we changed the sign to get negative 8. Negative 11 times 2, we changed the sign to get a positive 22. 23 times 2, but then we, that's right, changed the sign to get a negative 46. Seems to me that, well, not to me, someone else came up with this, it's just my job to teach it to you. If we change the sign here once in the x plus 2, we would just have to add things without changing the signs, right? So, the whole point of all this is that if I have a polynomial and I'm dividing it by something that has a form of x minus c, then because the numbers that I've highlighted are the ones that really matter, this process can be expressed in kind of a shorthand way. That process is called synthetic division. And synthetic division is really just a shorthand way to do what we've just done. So let me re-express the original problem that we had, and that is 4x cubed minus 3x squared plus x plus 1 was being divided by x plus 2. Here's the process. This x plus 2, remember we had to subtract, which was change the sign all the time, right? So we're going to take that 2, write down the opposite, negative 2. And because when we were dividing by 1, all those values didn't change every time we divided, we don't have to worry about writing that part down. This method says, hey, all we really care about is the coefficients in the dividend or the original polynomial. So, writing those down in descending order, and if there were any missing terms, missing degrees, we'd have to fill those in with zeros. And then I'm going to write this draw this little box here. And remember, for that first step, let's scroll back up. Because I was dividing 4 by 1, that value didn't change. And so every single time with synthetic division, that first coefficient that we wrote, we just write again. So bring down that 4. And then as you remember, we were multiplying and subtracting. We've already changed the sign. And so this actually becomes multiply and add. So negative 2 times 4 is negative 8. Add those together, I get negative 11. Multiply and add. Multiply and add. So 22 there, negative 2 times negative 11. 1 plus 22, 23. Multiply and add. Negative 2 times 23 is negative 46. And then add. And when I add, I get negative 45. And that negative 45 seems a bit familiar. Check it out. So do these other numbers. Again, this is just a shorthand way to express what I've just divided. Now, in the original polynomial, the 4 was the coefficient of an x cubed term. The negative 3, x squared. 1 was the linear term x. And that last one was the constant. Now, if I divide an x cubed by an x, my result is going to be x squared. Writing down the other terms as they seem fit, x constant, and then that last guy, remember, is the remainder. So this is a way of expressing that. The result of this division is 4x squared minus 11x plus 23, and there's a remainder of negative 45. So again, synthetic division is a shorthand way to do a division as long as the divisor is a linear binomial of the form x minus c.